Hello everyone, welcome to LT++. So in this tutorial we'll study ENDC, okay, and we'll cover purpose and its deployment options. Okay, and in upcoming lectures we'll also cover the types of bearers and the call flow procedure. Okay, so let's start with purpose. Okay, so why we need ENDC? Because if you look at 4G network, we have 4G core node, right, and 4G base station, okay, and this is my UE. So suppose if an operator wants to change its network to 5G from 4G, so it's not a easy job, right? You cannot perform it in a single day. Okay, so 3GPP has proposed a procedure and it is called ENDC. Okay, so E stands for EUTRAN, N stands for new radio, and DC stands for dual connectivity. Okay, so they have introduced 5G base station, we call it G node B at radio side, okay, whereas 4G core node will remain same as it was in 4G network. Okay, so this is my ENDC architecture, you can say, and okay, and here one important thing is there, G node B cannot directly communicate to 4G core network or EPC. Okay, so it's E node B which is able to communicate with 4G core node. Okay, so this is my S1 MME interface and this is my S1U interface. Okay, so if G node B wants to perform any correlated functionality, it first has to inform E node B, okay, over X2 interface. Okay, and one more important thing is there, this E has been written before N. Why? Because here the E node B is known as master node, okay, and whereas G node B is known as secondary node. Okay, so master node is responsible for signaling, okay, and signaling with that your core node, and along with this signaling it also has to take decisions like when to add this secondary node. Okay, when to add secondary node. Actually what happens when this UE moves to this 5G coverage area, so what it will do, it will send some measurement reports to 4G base station. Okay, now after reading the or after decoding the measurement report, this E node B or master node will take decision whether to add this secondary node or not. Okay, that's why we call it master node. Okay, so this call flow will cover in detail in upcoming lectures. Okay, okay, and one more important thing is that in phase 2 3GPP is planning to introduce the 5G core node. Okay, so then they will use 5G G node B and your UE. Okay, so this will be your standalone 5G network, right? This is my standalone 5G network, and this is my non-standalone. Why? Because operator has to use both E node B and G node B in its network. Okay, okay. Okay, so let me read the purpose again. So it's not easy for an operator to change its network from 4G to 5G in single day, that we have already seen. Okay, so 3GPP defined architecture where existing 4G core EPC will be used, and we introduce 5G technology at RAN side. Okay, and in phase 2 they are planning to remove 4G core with 5G core. Okay, so that will convert the ENDC architecture to standalone architecture. Okay, fine. So we are done with purpose. Okay, and one more thing, there is another option is also there, NEDC. We are not going to study it in detail. I'm just telling you that here your N stands for NR, E stands for EUTRAN, and DC stands for dual connectivity. Okay, so here NR will be your master node. Okay, why we are calling it master node? Because it is responsible for your signaling and that when to add the secondary node. Okay, that thing. Okay, so now let's come to the deployment options. Deployment options of ENDC. Okay, so 3GPP has proposed 3 options. Okay, so the first one is your option 3. The second one is your option 3A, and the third one is option 3X. So operator can choose. One of these 3 options. Okay, so this is my 4G core network. Okay, so first of all, I'll draw the common things in these architectures. So 4G core node will be common in all the architectures. Okay, 4G core node, and this is 4G core node. Okay, the next thing is E node B will be common. Okay, without E node B, these architectures are not possible. E node B means that is your 4G base station. P and my E node B. Also we need G node B also, right? Because it's a non-standalone approach, right? So we need both E node B and G node B. Here is also G node B. Okay, now let's come to the interface. So always S1ME interface will be there, S1U interface will be there. Okay, with E node B and 4G core node. Let me draw here also S1MME. We also call it control plane, and S1U. Here also S1MME and my S1 user plane. The next interface which is common in all the architectures is X2C. Because here 5G base station is not going to interact with 4G core node. Okay, so whatever functionality or information it needs, so first G node B will convey that information to E node B, then E node B will further proceed it with 4G core node. Okay, so X2C will always be available. Now let's come to the differences. So here in option 3, X2U will be there. Okay, whereas in option 3A, S1U between 4G core node and G node B will be there. Okay, remember it's not control plane interface, it's user plane interface. Okay, whereas in option 3X, both interfaces, that X2U and S1U, will be present. X2U and this S1U will be present with G node B. Okay, so these are the deployment options available for an operator. Okay, and generally operator prefers this option 3x. Okay, so that's all for deployment. Okay, and let's review all the important points from document. So ENDC, so there is no direct CP connectivity between GNodeB and EPC for CP. Okay, this we have already seen. You can also look here, this NR and EPC. No control plane connectivity is there between GNodeB and EPC, right? Okay, so 5G will interact with LTE Node B for any correlated functionality, right? So via X2, it will first inform LTE base station for any correlated functionality, and that LTE or eNode B will further proceed to complete that task. Okay, and in ENDC, LT work as a master node and R work as a secondary node. This I have already told you, right? Like this thing, that this eNode B is your master node and this is my secondary node. Okay, because it takes care of signaling with core. Okay, and also it will add the secondary node if required. Okay, and then UE first perform initialization with master node. After successful initialization, this MN would add one or more 5G secondary cells. Okay, so when you switch on a UE, so what UE will do, UE will first perform initial attach with this eNode B, that normal procedure, that RACH procedure. It will, this UE will follow the RACH procedure, RC connection establishment, everything it will do. Okay, and after that, if this UE moves in 5G coverage, then this master node will take the decision to add the secondary node, and it could add multiple secondary nodes. Okay, so this is the proper call flow we will see in upcoming lectures. Okay, and okay, after successful initialization, this MN would add one or more 5G secondary cells. Okay, okay, then LTE Node B and NRG Node B are using their own 5 MAC. Okay, so this will see, you will get better understanding of this point when we'll look at that difference between CA and ENDC. Okay, so that's all for today, and in upcoming lectures we will look at the CA versus ENDC. First thing. The second thing, the type of bearers. Okay, that is your SCG, MCG, split bearers, and also we'll cover the call flow procedure. And one more thing, that protocol stack will also cover. Okay, thanks for watching.